Adding and subtracting polynomials. Number one, add using algetiles. Now remember, algetiles are a visual representation of algebraic expressions. So inside each bracket, we have a separate polynomial. So let's start with the first polynomial for a. 2x's. Remember, an x is a shaded bar. Therefore, I'm going to draw two shaded bars. Minus 4, remember, a 1 is a small shaded box. A negative 1 is a non-shaded box. So I'm going to draw 4 non-shaded boxes. Now, move on to the next polynomial. 3x means I have 3 bars. Minus 5 means I'm going to have 5 non-shaded boxes. Now it says to add, so I'm going to combine these. When I combine them, how many bars do I have? Well, I've got 5 bars, or 5 x's. How many small boxes do I have? Notice they are all not shaded. Therefore, if I have 4 of them and I add 5 of them, I'm going to wind up with 9 small boxes. So, what does this mean or represent in symbols? Well, the bars are x's, so I have 5 x's, and the small boxes represent -1. Therefore, I have 5x minus 9. That's my final answer. Let's move on to b. For b, I have x squareds. Well, what represents an x squared is a large box. Since it's positive, it's going to be shaded. So I'm going to have 4 large boxes. I have -2x. Remember, an x is a bar, but it's a negative, which means I'm going to have 2 non-shaded bars. -1 is a non-shaded small box. Let's move on to the next polynomial. -7x. Well, an x is a bar, but this is a negative bar, so I'm going to have 7 non-shaded bars. +4. A 1 is a small shaded box, so I'm going to have 4 small shaded boxes. And 2x squared. They're positive, so they're shaded. I'm going to have 2 large boxes. Now, when I combine these, how many large boxes do I have? Notice they're all the same shading, so that's going to be 2 plus 4, or 6 large boxes. How many bars do I have? Notice that they are all not shaded, which means I can take 2 of them and add 7 of them to give me 9 non-shaded boxes. Now, with the small boxes, what I notice is one of them is shaded, 4 of them, or one of them is not shaded, 4 of them are shaded. So what happens here is that one shaded will cancel out with the one non-shaded, leaving me with 3 shaded boxes. So in symbols, what does this represent? Well, I've got 6 large boxes, which gives me 6x squared. I've got 9 unshaded bars, which gives me -9x, and I've got 3 boxes, which is +3. There is my final answer. Now, we can also do this using symbols. Now, to add using symbols, the first thing we need to know is why are the brackets here? And in this case, all the brackets do is show me that we are starting out together with these particular polynomials. So there is no number in front and no sign in front of each bracket. So there is no negative consequence to me removing the brackets. So I am now able to collect my like terms, -6x and 3x, -4 and -9, and I can combine them to give me -6 plus 3x is -3x, -4 minus 9 is -13. These are not like terms, so that is my final answer. Try B and I'll do it in a minute. Okay, so we're back here. Notice I've got a binomial added to a trinomial. I have to ask myself, why are the brackets there? And the answer is because there is no sign in front of either bracket and no number to multiply it, that these brackets are here to say that these polynomials have started out together. and there is no negative consequence to us removing the brackets. At this point, I'm going to collect my like terms. Well, first of all, I've got negative 2x squared and negative x squared as like terms. I've got 7x and negative 3x. And finally, I've got a positive 5. So 2x minus x, 2x squared minus x squared gives me negative 3x squared. 7x minus 3x gives me positive 4x, and I've got a 5 on the end. That would be my final answer because none of these are like terms. When we subtract, which is considered more difficult, we have to add the opposite. So let's start by figuring out how do we find the opposite expression. To do this, we ask ourselves, what would we add to the expression to make it equal to 0? So 5x, what would I have to add to 5x to get 0? Well, that would be negative 5x. Notice, all I've really done is change the sign, or multiply it by negative 1. I'm going to do the same thing for b, 3x minus 1. Well, I'm going to change the sign, or multiply everything in the polynomial by negative 1. 3x becomes negative 3x. Negative 1 becomes positive 1. Stop this video now and try C and D, and I'll do them in a minute. Okay, for C, again, I want to multiply everything by negative 1 or change the signs of everything in the polynomial. So I multiply it by negative 1 and negative 6x becomes positive 6x. Positive 4 becomes negative 4. If you look at D, you'll notice that this is a trinomial. Now, does that make it a little more difficult? Yes, but we follow exactly the same pattern. I want to change the sign of every single term. So there's 3 terms, I'm going to change 3 signs, which is the same thing as multiplying it by negative 1. Negative 3x becomes positive 3x. Positive 5 becomes negative 5, and negative x squared becomes positive x squared. Now, the entire reason we did this is so that we can subtract polynomials. Now it says simplify the expression. Again, what we're going to try doing is making it as small as possible by combining like terms. However, because we're subtracting, it means we're going to have to change the signs in the second bracket. So, number 1, we have to ask ourselves, why are the brackets here? For 2x minus 4, there's no sign in front, there's no number to multiply each term by, which means that the bracket is here to tell us that this polynomial has started out together. There is no negative effect for us if we eliminate the brackets. However, the second bracket is there to tell us it started out together, but also that we are subtracting each term inside the second bracket. So what are we going to do? We are going to add the opposite. So 5x becomes negative 5x. 7 becomes negative 7. At this point, I'm going to collect my like terms. 2x minus 5x is negative 3x. Negative 4 minus 7 is negative 11. These are not like terms, so that is my final answer. Stop the video and try 2 now, and I'll do it in a minute. All right, so number 2. Why is the first bracket there? Just to tell us that they started out together, so we can eliminate it without any consequences. Why is the second bracket there? To tell us that they started out together, but also that we are subtracting each term in the second bracket. So to eliminate the bracket, I must add the opposite. The opposite of negative 7x is positive 7x. The opposite of 4 is negative 4. At this point, I'm going to collect my like terms, which are negative 5x plus 7x and 8 minus 4. So negative 5x plus 7x is 2x. 8 minus 4 is positive 4. These are not like terms, therefore that is my final answer. Looking at number 3, Notice we now have trinomials, which makes it a little bit more difficult, but we follow exactly the same procedure. So, why is the first bracket there? It's there to tell us that this polynomial has started out together. There's no sign or number in front of it, so I can eliminate it without any consequences. Why is the second bracket there? Well, it started out together, but also because we are subtracting each term inside the bracket. So what does that mean? That means we have to adjust the signs to keep the integrity of the question. So we add the opposite. The opposite of 9x is negative 9x. The opposite of negative 7 is positive 7. And the opposite of 5x squared is negative 5x squared. You can also think of this as multiplying everything in the bracket by negative 1 to remove the bracket. At this point, I'm going to collect my like terms. I notice that 2x squared minus 5x squared is going to give me negative 3x squared. Negative 3 minus 9x, negative 3x minus 9x is negative 12x. And finally, 5 plus 7 is plus 12. Notice none of these are like terms, therefore that is my final answer. Try number 4 and I'll do it in a minute. Okay, number 4. Why is the first bracket there? Just to tell me that it started out together. So I can eliminate it without any problems. Why is the second bracket there? Well, it's because I am subtracting everything inside the bracket. So how do I remove the bracket? I multiply each term by negative 1, or I add the opposite. Positive 11x becomes negative 11x. Positive 7 becomes negative 7, and positive x squared becomes negative x squared. At this point, I've gotten rid of my brackets. I can reorganize this, putting my like terms together. 2x squared minus x squared is x squared. 9x minus 11x is minus 2x, and negative 5 minus 7 is negative 12. At this point, none of these are like terms, so that would be my final answer. Our final question is a problem. We are asked to determine the unsimplified expression for the perimeter and simplify. Well, what is perimeter? Perimeter is the distance around the object. So how do we find perimeter? Well, we add all the sides together. Now, notice each side is a polynomial. Therefore, I'm going to put them in brackets to start with. Now, I am adding, and there's no number in front of each bracket, so there are no consequences to me removing the bracket. I don't have to worry about changing any signs. At this point, I'm going to collect my like terms. I have 3 terms that have x's, and I have 2 terms that are constants. So x plus 2x is 4x. 2 minus 4 is negative 2. Now, all distance has to have units, but we aren't given any, so because we want to indicate that it's a distance, we put the word units at the end. So my final answer is the perimeter of this object is 4x minus 2 units long.